All right, so the next one we're going to do is a chemical reaction. It says a chemical reaction begins with a certain mixture of chemicals that reaches 95. The reaction activity is measured in units, U per 100 microliters of the mixture, so 100 μl. And measurements during the first 18 minutes of the mixture reaches 95 degrees Celsius are listed in the table here. We need to find a logistic model for the data and what is the limiting value for this logistic function. Then we'll use the model to estimate the average rate of change of the reaction activity between 7 and 11 minutes. And then we're supposed to numerically estimate to the nearest thousandth by how much the reaction activity is increasing at 9 minutes. And then we're supposed to write a sentence of interpretation for the answer to part B and C. All right, so logistic model, that means we have to go get a calculator. And so I've typed the data in. This is what it looks like. And it looks like it's going to plateau here and it's plateauing here. So that's good. So now we just find our model and logistic here. Let's arrow down. Let's put it in vars 1. All right, so that's our first thing we need. We need to actually have that value. So maybe let's go ahead and copy that so we can go look at something else. We'll just keep it in a form here. And if we look at our graph, it looks pretty good. All right, so what was our limiting value basically? In this case, it looks like the limiting value is the C is 1.93689. So let's go back over to here. For A, the logistic model was this. So let's write that down. Actually, you know what? Let's just copy it, close, and we'll paste it in here. And then we can write it, and then we can get rid of it. So our model is going to be, now this is activity based on time is equal to 1.9368975 23 all over our 1 plus 29.06375338. And then we have e to the negative. Now b is 0.4211097485. And then it's times t. And that's all in the denominator. And so that is our function. So now let's click on that and let's delete that. So now we have our function. And so limiting value, that's going to be our numerator. And so the limiting value is equal to 1.93. I don't know how far we want to go, maybe to the 7. That's what I would do, 937. And what's the units? It's U per 100 microliters. Okay. So that's our function. That's our limiting value. And now this one, what is A? Well, remember, we have to kind of have our units here. We have U per 100 microliters. Gives a measurement of reaction activity, basically. And again, this is for t less than or equal to 18, greater than or equal to 0. So, we didn't do it on the others. We just left it in the table on a lot of those. We didn't write all that down, but we have to kind of keep those in mind. All right, so now it says use the model to estimate the average rate of change of activity between 7 minutes and 11 minutes. All right, well, what we're going to do is we're going to use that values and plug it in. So we're going to have the AROC, the average rate of change, is equal to. Now we need to have our A of, now we had 11 minus A of 7 all over 11 minus 7. Okay, so we're just going to plug in all that with A 11 and A of 7 and then 11 minus 7. And if we do all that, I'm going to do that on my calculator on hand here, so it's a little quicker. Then, all right, so I'll pause and I'll come back after I type it all in. All right. To save time, what I did was I just used my Excel again. I plugged in the value for 11, and then I plugged in the value for 7, and then I divided by 11 minus 7, which is 4. And oops. And when you get done, it's 0.186 roughly. So going back over here, we get the 0.186 for the A rock. All right, so now what's the next question? It says numerically estimate to the nearest thousandth by how much the reaction activity is increased at 9 minutes. All right, so now we need to go back to our Excel. And we have our function. And so what we have to do is at 9 minutes, we're going to go 8.9 on down until we get the 89999, very, very close to 9. And then the other way going down from the right, 9.1, 901, 90001. And then we plug in our value for, our x into our original function. And then we get these values for f of x. And then slope, we just calculate it based with 9 minus the one with f of x, which is the 8.9, and then divide that by 9 minus the 8.9. And then we do that down for all of them. And we get 0.195, okay, from the left. Do the same thing from the right, except, now we have the upper part of the nines. And again, we get 0.195 from the right. So let's go ahead and copy this so we can paste it into our PowerPoint. And so we copy that. And now we can go to the PowerPoint again. And let's paste. Now that's going to kind of cover up stuff. So let's shrink it down a little bit. All right, so we have all our information here. Now, what was the other idea? So we had to have C. Okay, well, C is going to give us, is going to be, now we had, what was our A of T? So A prime of 9 is approximately 0.195, and our units is U per 100 microliters, okay? All right, so that's C. What's D asked for? Write a sentence interpretation of the answers to B and C. All right, so B, we had our, what do we have for B? Use the model to estimate the average rate of change. Okay, so this was B up here. Didn't label that one. So for D, we can say between 7 and 11 minutes after the reaction mixture reached, and I think it was what temperature, 95 C. The reaction activity increased by an average of 0.186 U per 100 microliter per minute. Okay, because these are minutes down here, so it's the U per 100 microliters per 1 minute. Okay. And the last one was this. And so for that one, we can say after 9 minutes, the reaction activity, oh, where'd the rest of that word go? Was increasing by 0.195 U per 100 microliters, and then again per minute. Okay. All right, so did we get all the questions now? Interpretation, yeah. Okay, so that would be what I would interpret that as, okay? Again, we used Excel to get all the calculation data, and then we just had to do the interpretations by ourselves. So let's stop there and we'll come back.